Hi, and welcome to the 10 square meter workshop. In this episode, I want to talk about both automatic and remote switching of your extraction system. After this, those who have watched my other videos will know I have a remote clip system for switching my extraction on. This means I can switch it off and on from anywhere in the shop. I believed, because I have a variety of tools, that it would be too complicated to arrange an automatic switching, where the extraction comes on when you switch on the tool and off when you switch the tool off. However, almost all of my use comes from one power socket, so I have added automatic switching to that. I have retained the wireless system for use with cordless tools. You may be interested in installing either or both of these systems. I will go through the process so that you can decide.
The easiest is the wireless remote. These can be bought on Amazon, eBay or other suppliers for around £20 in the UK. Make sure you get the mains version, 110 to 240 volt. These can be wired in line with your extractor and you are done. If you're wiring the extractor directly as I do, rather than through a plug, you should fit a fused isolator like this.
Power sensing is more complicated. Although commercial units are available, it's cheaper and more integrated to build your own, especially if you want the wireless version too. The starting point is a current sensing switch like this one.
It's not suitable to switch the extractor directly. It cannot switch enough power. You could just add a mains operated relay like this one.
This will work, but the extractor will switch off as soon as the tool is switched off. You may be happy with this, but you really want a delay to clear the hose. Around 5 to 7 seconds is suitable. This can be done using that popular chip, the 555. If you're up for a little electronics, this is how I did it. A word of warning, this is not a complete step-by-step guide. If you need that level of information, you probably shouldn't be building this.
Here is a circuit that I developed for the unit. Take a screenshot if you intend to build it. It uses a 12 volt relay which stays engaged for roughly 6 seconds after the signal from the current switch ends. Make sure it has adequate switching capacity for the extractor. Mine was 240 volts 5 amps with contacts doubled to give me 10 amps capacity. There are only a few components involved and it fits on a very small piece of strip board. Here is the assembled board ready to test. I fitted it into a small box that came from an old ceiling light power supply, but any box would do. It's quite small. It needs a 12 volt DC power supply. I used an old wall wart unit from a long gone piece of equipment. I cut the plug part off and wired it direct. Remove the live wires, with a power isolated of course, from the socket you are going to use and use a single connector block to extend the wire long enough to pass through the hole in the current detector and then to the socket. Check and adjust the current switch until it operates using the lowest power tool you intend using.
Wire the items together and test. All the circuitry should be after the isolator for safety and so that no power is being used unless the system is armed. You may wish to mount the whole system in a box. Mine is inside the wall.
Hidden from view.
All my power tools use this plug-in system. So use a common socket. Does it work? Let's try it. Also works for the bandsaw. So, whether you build either or both of these switching systems, I hope it makes your extractor easy to use and that you feel it is a worthwhile enhancement. Till next time.